So I'm Xavi Planes, and I'm a developer of GIMIAS framework, and I started working with GIMIAS like 5 years ago. In this webinar I will present you some of the new features of the GIMIAS version 1.4 and 1.5. So we'll start with the list of new features that have been included in the two versions, 1.4 and 1.5. And in this webinar we will focus on some of these features that you can see in bold. So to explain you these features, we will focus on 3 use cases. The first one is the Angio Images. We will use a cerebral aneurysm image to show you these features, the XNAT, FTP, SSH execution and clinical reports. The second use case is cardio images. We will use cardio image to show you the advanced manual segmentation feature, and finally we will see the batch processing using another cardio image. Okay, so we will start with the webinar. Just 2 remarks. The first one is that instead of using to ask the questions at the end of the webinar, please ask your questions when we finish showing one of the features. Then it's easier to explain you better and to interact and to use the current data that is being used in the explanation. And the second remark is that if you could please mute your microphone unless you need to speak to avoid the noise of the webinar. Okay, so we start with the first use case, is the Angio Images. So the first thing is to open the GIMIAS 1.5. I will use the 1.5 release number 3 because this includes a new feature that is not yet released in the public website, but the rest of the features are already included in this version. So I will select the plugins I want to load. The first one is the scene view, the remote data plugin, the security, XNAT, clinical report, and SSH plugin, and I press OK. So now the plugins we will use for this use case are loaded. So the first thing is to open the working area for XNAT, and you can see this is the working area for accessing the XNAT database. XNAT is an open source imaging informatics platform that can store DICOM images and another kind of resources related to a patient, and we can divide the data in different databases, relational databases related to the different projects. So we will manage the connection to connect to the XNAT server. We will add a new connection, and to configure these parameters, we will go to the GIMIAS website. We go to support, IT services, and here we look for XNAT. Then we can see the parameters, the service URL. We copy this URL and we fill this field in the configuration. The name of the node will be GIMIAS. The user, we come back to the website, user is guest, and the password is the same. Okay, so press OK, press apply, and now as you can see we can select this node and we can query the database what is to retrieve the list of patients that are already stored in the database. This can take This can take some time to query the server and retrieve the list of patients and the detailed information for each of the datasets that are in the server. You can also use the web browser to go to this server and see what are the different projects and patients that are stored. And we can also use the different fields. You can see here the gender, the year of birth, to select a specific patient or a specific dataset. Once the list of patients is retrieved, you can see in the results the different patients that are available. Here I will select this. The last one is the cerebral aneurysm cropped. I will click download to download this dataset in my computer. Here you can see the detailed information. You can see the ID, the URI, the label. Okay, here we have the image downloaded from the database. You can see this is a 3D array image of a vessel of the cerebral aneurysm. This image is a cropped image, so it's very small image just to show you in this presentation. So what can we do with this image is to segment the image and obtain a surface mesh. For this we will use a technique. A technique is called GAR segmentation. It's an algorithm based on geodesic active regions and is optimized for segmentation of vascular tissue. So to use this segmentation algorithm, we will configure the SSH node. We will add a new node. This is a server that is available in the UPF. I need to fill the host name, the port and the username, and then I can test the connection to the server. Then it asks for a password. I introduce the password, and the connection has been successfully. So now I can connect using SSH protocol to the server, and I can use secure data communication and execute a remote command to the remote server. So we will use this SSH protocol to execute the segmentation on this image that I have loaded in GIMIAS in my local computer. We will send the image to the remote server and execute the segmentation and retrieve the output result to the local computer. So now what we need to do is to configure the plugin provider. So we click here, import new plugins, SSH plugin provider. We select the SSH node. Sorry, I forgot to come back here and press apply. And now we can come back to the import new plugins, SSH node. We select the node I just configured, and now you can see here it says remote GIMIAS versions. So we can select what is the GIMIAS version we want to use. So we select 1.5, click OK, and now you can see that here in the available plugins there is a new group of plugins. It's called SSH command line, and it says what is the name of the server and the folder. And now we will look for GAR segmentation. So in the filter field we put this the word GAR, and we select GAR segmentation. You can see that this filter, this plugin is in the SSH using the SSH protocol. We click OK. Now if we go to the toolbox, we go to the processing option. We can search for the GAR segmentation, and we need to select the input volume we want to process, what is the modality of this image, 3D array, and what is the output. Is an output surface mesh. and we press apply. So now this image is sent to the remote computer using the SSH protocol. The local computer authenticates to the server, sends the image. The guard segmentation command line plugin is being executed in the remote server, and finally the output mesh will be downloaded to the local computer. This process can take some time because this algorithm is optimized for vessel tissue, for vascular tissue. But after this execution, we can see the surface mesh, and the advantage of this algorithm is that it is very automatic, so we don't need to configure any threshold related to the image. Okay, here we have. This is the surface mesh that we obtain using this algorithm. Now the next steps for using this surface mesh is to clean the mesh and remove the small objects, and use mesh editing to refine the different parts of the mesh. Okay, so this is the SSH feature, and now what we will see is the FTP to download a surface mesh already processed for this image. So we go to the website of GIMIAS. We can see what are the URL. What is the URL of FTP? We go to the FTP MSV. We go to cerebral aneurysm morpho, and here we can copy the URL of this data. And if we go to File, Open Remote Data, we can introduce the URL and download the BTK surface mesh from the website. You can use any FTP, any FTP server. So here, if we hide the output of the guard segmentation that we just executed, you can see this is the downloaded surface mesh from the website. If we can compare this with our result, you can see that they are very similar. So this is the we have seen the downloading of dataset using FTP protocol. So the last thing we will see in this use case of Angio Images is the clinical report. So we go to the view toolbars and we select clinical report toolbar. So the first thing we will do is to create a new report. We add a new report. We put the report title, the author, the patient ID, patient name, the sex. We can add a logo, I will use the GIMIAS logo, and general comments. This is my first report. Okay, and now we can add a snapshot to this clinical report. We will add the input image. So we click on the first icon, add screenshot to the clinical report. We can put here the title and the comments. And we add this snapshot, and we can also add a snapshot of the surface mesh. This is the aneurysm and this is computed using GAR segmentation. And finally, we can also add a comment to the clinical report. So the comment will be, this is my first comment. Okay. And here we click on the last icon. We can see the reports and the different snapshots that I just captured, and the comment. We can also order the comments and the snapshots. And finally, we can press the create and open a clinical report. This feature will create a PDF of containing all the information with the input image, the comments I added for the image, and the surface mesh snapshot, and the comments I add, and the general comments I added to the clinical report. And I also can print this report and save it into another folder. So this is the last feature of the first use case to the clinical report. So I think I forgot to ask for questions. I think I went very fast through the different features, but now is I think we can take some time to ask for questions if anybody has any question related to any of the features we have seen. So I just review the features, the XNAT features, the FTP, SSH execution, and clinical reports. Does anybody have any question related to any of the features? Okay, so then we will go to the next use case. Yes? Yes?
Or think about the recent debacle on Wall Street. Of course, we saw in 2008 the collapse of our economy thrown over a cliff by a collapse on Wall Street. And why is it we came to this bubble and disaster? Why did we
I didn't hear very well, but I think you're asking for the what is the platform that is supported by the SSH execution. So the yes, well, the supported platform is Linux. This connection to using SSH, now we have tested it using Linux platform, and to configure this execution we need to install GIMIAS in the remote computer and execute it once. Then the configuration is stored in a personal folder of the user, and this plugin, SSH plugin, will automatically scan all the GIMIAS version that have been executed in the remote computer, and automatically show what are the available plugins that can be executed in the remote computer.
Its picture looks something like that, but it's not the money that inspires a Rob Blagojevich. It's not the money in brown.
Okay, so if there are no more questions, then we will move one step forward to the Angio Images use case.
Instead, the money here is the money described in this extraordinary book by Bob Kaiser, So Damn Much Money.
Okay, so this is the DICOM plugin. Now we will see the DICOM Browser functionality. We will open a DICOM RT. I have it in my computer. You can also download it from the website. DICOM RT. DICOM RT is DICOM radiotherapy. It's a specific kind of DICOM images for radiotherapy. And here, if we go to the RT extract dataset, we can see the different DICOM entries. And in this GIMIAS version we can also inspect the sequence DICOM entries. Here you can see the structure, set, row sequence, and we can see the different values of each of the items. We can also search for a specific DICOM entry. For example, we can say Roy, and here we can see the different entries. Time. Yeah. Okay, so this is DICOM browsing, but for the next feature, that is the advanced manual segmentation, we will use another dataset that is cardio image of the heart. We go to cardio, MSV, and the MRI. You can also download this dataset from the website. This is a DICOM image of the heart, MRI image, in time. So we will enable the interactive segmentation and use the select the reference image, use the region growing, and we can click on the image, move the mouse button, move the mouse up to increase the region, or move the mouse down to decrease the region we want to segment. So we need to find where is the optimal position here. Okay, and we can deselect the region growing tool. We can zoom it. We can also use another tool, like for example the lasso tool. We can click with the left mouse button to draw line, and all the pixels that are inside of the lasso will be painted with red color. We can use another tool is the paint tool. We can select the brush size and paint the pixels we want to segment, and here we can also remove using the wipe tool. Another interesting tool that will be released for the GIMIAS version 1.5.3 is the contour segmentation tools that are in the second row. We will start with the polygon tool. We can click shift and left mouse button to add new points, and the points are connected using a contour, and we can press the space key to paint the inner zone. You can see all the available keys using the help and acknowledgement button. Here you can see the space keys to paint inner zone, the shift and left mouse button to add a new point, and so on. And another method for the contour is the spline contour. So we click on the spline contour, we click on the image, and here you can see that the points are connected using a spline. If we see that there is some region that we need to segment, we can click the tab key, and we can add a point between these 2 points, for example here. We can press the space key to paint the inner zone. And finally, there is another interesting tool, but it's called the live wire. I will start with an empty image. Click on the live wire. I select, I add a new point, I add a second point, and move it. Okay. And now the live wire is computing what is the best connection between these 2 points using the gray level of the image. Okay, so we can come back to the previous image. We select again the contour segmentation, we click on the image, and the contour is computed automatically, and we can use the wheel mouse to move to another slice, and the contour points are kept in the same position. So we can move the points. We click on the point, we move it. We click on another point. We think there is a point that we don't need it, then we can click the delete key to remove it. Now we can press space key to paint the inner zone, and we can also move to the next time point, keeping the same points, and to continue the segmentation of all the time points. And finally, for this feature, we can see how can we interpolate between different slices. So we unselect this tool, we go to another slice, and we use the region growing to segment this slice. And now we unselect this tool, we move up, and you can see that there is a red line. This is a interpolation between the first slice and the second slice is segmented manually, so it automatically computes the interpolation. So if I click the button accept for all slices, then all the slices will be segmented automatically using this interpolation. So I think this is we have seen all the features of the advanced manual segmentation, and we have also seen the DICOM browsing functionality. So now if you have any question related to any of these features, please ask your question. Okay, so then yes, the answer to your question is that you can use any of the tools. You can use the region growing, or you can use the paint tool, lasso tool, and then well, I can show you again. We can come back to the dataset. We open the input image, we click on the interactive segmentation, we select the image, and we click, for example, region growing to segment the left ventricle. We unclick this tool, and now we can use the contour tool. We click on the image, and then the points are automatically computed for the region that is already segmented in the image. I think is this answering your question? Okay, perfect. So we will select what are the plugins we need for this use case. We unselect all the plugins. We just select Scene View and the Web Services plugin. Now what we will do in this use case is to configure an external application and execute it in GIMIAS, the first thing, and the second thing we will do is to use Taverna Workbench to execute a workflow and to process a set of images. So let's go for the first step, is to configure an external application. So we will use the CMTK. CMTK is a computational morphometry toolkit that has a set of tools for image processing. So I downloaded this package, I installed it in my computer, and we can see the folder where I installed this package. CMTK 2.1, CMTK. Okay. Here you can see all the executables that are available in the package. So we will use, I think it was the filter application. So we go to GIMIAS, to Advanced Custom Application Manager, and we will add a new application. What will be the title of the application? We will say Gaussian. Category, we will say filtering. Gaussian, we can fill the title, description, executable. This is a very important field. We need to configure what is the executable we want to use. We will select filter. The working directory, we can leave it empty, and we can press apply. So we will configure a new group of parameters, and a new parameter in this group. We'll configure a float parameter. The name will be Gaussian, and the format is Gaussian, and the value of the float. The label will be Gaussian, and the default value is 1.0. Now we will configure the input and output parameters. We need to put the letters I and O, and we will excuse me, this is not we'll remove. We say IO, and we press apply, and we add a new parameter. This will be an input image with the name input image. This index will be 0, and the label will be input image, and the file extensions required by this application is .nii, and the second parameter will be the output image. The index will be 1, this is the parameter number 1, the label will be output image, and the file extensions will be nifty compressed. Okay. So we just configure the Gaussian external application, configuring what are the arguments that are expected by this application. For example, if we go to we open a command window, we go to the folder of the application, we execute filter and help. Here we can see what are the supported arguments of this application. I just use the first one, is the Gaussian with the float value, and the input and output are the input and output images that we have just configured. Okay, so then we will move forward to the last use case. So we unselect all the data. I think something went wrong, so we'll restart game. Yes, Okay, so let's go to the chat. Yes, the answer to your question is that you can use any of the tools. You can use the region growing, or you can use the paint tool, lasso tool, and then well, I can show you again. We can come back to the dataset. We open the input image, we click on the interactive segmentation, we select the image, and we click, for example, region growing to segment the left ventricle. We unclick this tool, and now we can use the contour tool. We click on the image, and then the points are automatically computed for the region that is already segmented in the image. I think is this answering your question? Okay, perfect. Okay, so then let's move to the last use case. So we will select what are the plugins we need for this use case. We unselect all the plugins. We just select Scene View and the Web Services plugin. Now what we will do in this use case is to configure an external application and execute it in GIMIAS, the first thing, and the second thing we will do is to use Taverna Workbench to execute a workflow and to process a set of images. So let's go for the first step, is to configure an external application. So we will use the CMTK. CMTK is a computational morphometry toolkit that has a set of tools for image processing. So I downloaded this package, I installed it in my computer, and we can see the folder where I installed this package. CMTK 2.1, CMTK. Okay, here you can see all the executables that are available in the package. So we will use I think it was the filter application. So we go to GIMIAS, to Advanced Custom Application Manager, and we will add a new application. What will be the title of the application? We will say Gaussian. Category, we will say filtering. Gaussian, we can fill the title, description, executable. This is a very important field. We need to configure what is the executable we want to use. We will select filter. The working directory, we can leave it empty, and we can press apply. So we will configure a new group of parameters, and a new parameter in this group. We'll configure a float parameter. The name will be Gaussian, and the format is Gaussian, and the value of the float. The label will be Gaussian, and the default value is 1.0. Now we will configure the input and output parameters, we need to put the letters I and O, and we will excuse me, this is not we remove. We press, we say IO, and we press apply, and we add a new parameter. This will be an input image with the name input image. This index will be 0, and the label will be input image, and the file extensions required by this application is .nii, and the second parameter will be the output image. The index will be 1, this is the parameter number 1, the label will be output image, and the file extensions will be nifty compressed. Okay, so we just configure the Gaussian external application, configuring what are the arguments that are expected by this application. For example, if we go to we open a command window, we go to the folder of the application, we execute filter and help. Here we can see what are the supported arguments of this application. I just use the first one, is the Gaussian with the float value, and the input and output are the input and output images that we have just configured. So we will just test it and see if it works. We open the MRI image. Okay, there's something wrong with when loading the image. We will open again the image. No. Okay, sometimes there's something wrong when loading an image. In this case, I need to close it. This happens when we load and unload plugins without restarting GIMIAS. This is something we are working on it to see if we can fix it for the next release. So we open again the image and we load the Gaussian that we just configured. We select the Gaussian filter and we can see the parameter we configured is the Gaussian with the value 1.0. So we just need to press apply, and the external application has been executed. You can see the difference between the input image and the output image. So this is the blurred image, and the input image is is not blurred, is the original one. So the next thing we will do is to load the filter. This is another external application that I configured before, and now we will use Taverna Workbench to execute a workflow using this external application. Taverna is an open source software that is used for scientific workflow management system, and we can create workflows composed of different applications and create pipelines, for example for batch processing or parameter sweep. I will remove previous configuration. So this is Taverna. Here in this part you can see the different services that are available, and in this part you can see the diagram of the workflow that we are composing. So the first thing we need to do to use Taverna and GIMIAS is to go to Edit Preferences and select Web Services plugin that is already selected. We go to the Web Services configuration, and here you can see the default parameters. So by default the web services are exposed in this URL. We click on the URL with the right mouse button and copy the URL, and we start the web services server that is already started, and we close this window. Now we can unload all the data and move this window to the left part, and we go to Taverna. So we import new services. We use Wisdol service option, and we put here the URL. Click Add, and here you can see all the web services that are available. So you can see here the Gaussian and the filter. These are the two applications that we configured in GIMIAS, and we have some default services that are landmarking and visualization. So what we'll do now is to create a workflow using the filter application. So I already did it before, so I don't want to spend too much time configuring this workflow, so I just will load it. So this is the workflow. So you can see here at the top these are the inputs. So here is the input folder where it contains all the input images. So to configure this input parameter, I will go to the input folder. I have my images. So these are the 22 images I want to process. The Gaussian is the input Gaussian value of the filter, and this bin shell script we can edit it. What it does is a JavaScript that will list the files of the folder and create a list of all the files that are inside the folder. Then for each file it will apply a filter that is the Gaussian blur, and this filter will be executed in GIMIAS, and finally the output image will be written in the same folder of the input image here. So let's execute this workflow. We press the run the current workflow icon. We need to set the values of the input folder. We will put the folder where I have my images, and the Gaussian value I will put 0.5, and we can just run the workflow. Now the application, the Taverna application, will execute the workflow step by step, and we call the filter in GIMIAS website. In GIMIAS application, you can see here the different executions. And it finished the execution of the 22 images, and here you can see the value of the output image that has been processed. So we come back to the folder, and these are the output images of the workflow execution. So we just open the input image number 1, we open the output image number 1, and here we can see the difference between the two images. As you can see, they are very similar because the sigma value I used for the Gaussian is very low. And this is just an example of using Taverna Workbench and GIMIAS to execute biomedical imaging workflows. So we can use this feature to increase the complexity of the workflow and add more steps, for example using automatic segmentation algorithm like output threshold, and using marching cubes to create a surface mesh and iterate over a set of input images. So I think this we finished the last use case. So if you have any questions, please ask your questions related to any of these features or the features we have seen before. Okay, so there are no more questions. So anyway, if you have more questions during the next days, then you can send us an email using mailing list or GIMIAS website. You can find the different mails you can use for contacting us. And what else? We will also upload this video of this webinar into YouTube, and this will be available in the website for anybody that can would like to see this webinar online. And finally, the release of version 1.5.3 will be released during this month. We still need to fix small bugs, like you can see today. Like when we load and unload plugins, sometimes it crashes. Then we need to fix this bug and another small bugs that we have in the list of backtracking. But I think at the end of this of the month will be available the new release. Okay, so if there are no more questions, thank you very much for your attention and for attending this webinar. And I hope we can repeat this webinar next month using with focusing on another topics that could be interesting for us. And okay, so thank you very much, and see you next time.